Okay, this is TempleOS 5-minute random code walkthrough, episode number 6, and I'm your host, Terry Davis. So here we go, Alt-B to find some random code. And where are we? We are in GR bitmap. Okay, what this code is for blotting bitmap. So what we have is there's a destination device context and a source device context. This is the destination, this is the source. So what we're dealing with is a device context is a structure. It has a width, a height, then it has a body, which is it has some other stuff, a pen width, a color, brush. It's a device context. Then it has a body, and this is an array of U8s. So there's one byte per pixel, and it can be 16 colors, or it can be transparent. It's not 256 colors. It's not 256 colors. It's only it's 16 colors, or FF is transparent. So when we blot, let's see what we have to do. Basically we trim the width and height based on overlap, get that figured out so that we have H2 and W2 for width and height, and we go through the standard startup for each graphics routine. If it's we record the extents, this is a feature that you can turn on record extents, and then it'll expand a bounding rectangle. And if you set don't draw on the device context, we return early. Otherwise, we process 8 pixels at a time, with some leading and some trailing. We have some leading pixel. We align to an 8-byte boundary, and we have leading pixels and trailing pixels. Now, let's see. Color is determined by the image. Let's see how we handle 8 pixels at a time. There's raster operations. We can check for collisions. We can convert a mono image into a color. What that does is, let's say you want to draw a mono image in yellow, then what it does is it uses some arrays of let's see, you can see it's transferring 64 at a time. Color mask, let's see. So if we're doing a mono, the color mask is set by 2/8 colors. What 2/8 colors is this is a let's say dump GR 2/8 colors. This is an array of it's 8 zeros, 8 ones, 8 twos, 8 threes, 8 fours, 8 fives. So there only 16 are used plus the transparent. So it makes we want to process 8 at a time. So this loads in 8 of a certain value, and then we do the leading pixels. Then we do the pixels 8 at a time. Then we do the trailing pixels. You know, this is pretty close to the. It's not that many orders of magnitude different from the 640. So if we do a rectangle that's 40, then that means we probably have 5 leading, 5 trailing, and only two chunks of 8. So that's if it's a mono, we basically do a Boolean to test Oh, we're dealing with Z buffer as well. When you deal with 3 dimensions, if you have a Z buffer, this part of the if is if it's a Z buffer, and that means we check against the oh, this is the Windows Z buffer. This is not the graphics Z buffer. We don't use the graphics Z buffer on this. When we have we don't have a bitmap for each window. We just have one master bitmap, and all windows are on an 8x8 pixel grid. You can see when I move this around, it moves up a text character. So the Windows Z buffer is that's just to see if let's say over here we say gr. This is similar. GR rectangle. CDC star DC GR alias DC alias. Then we say GR rectangle DC comma. Let's set the color DC color equals red. GR rectangle DC 100. Let's do 300 comma 200 comma 200 comma 200. Oh wow, that's not what I expected. I expected it to obey the oh, that's for the persistent layer. I don't know what happened. Anyway, sometimes it obeys the window. I guess persistent layer doesn't obey it. Maybe that's a bug. I don't know. Anyway, I was expecting it to obey the Z buffer for the window. Oh well. Well, that sucks. Oh, maybe I'll have to investigate that. DC fill. So, oops. Anyway, so that's what that Z buffer is supposed to be. I don't know what happened. Maybe the persistent layer doesn't. It should obey it. Anyway, and if we have, well, anyway, so it has leading and trailing that align to a 64-bit, 8-pixel. So we transfer 8 at a time. We do leading and trailing, and then we transfer 8 at a time during the middle. So that's what this is.